All right, let's pull back the curtain on something you do every day. We're going to trace the secret journey your data takes, that hidden world that fires up the second you click a button and ends with a powerful business insight. Think about it. You're scrolling, you see something you like, and you click buy. A couple days later, a package shows up at your door. Simple, right? Well, not exactly. In that split second, your order, just a single piece of data, kicks off this incredible, invisible journey. So what is really going on back there? Okay, so the very first stop is a place built for one thing and one thing only: pure, unadulterated speed. This system's entire job is to grab your purchase and record it. Instantly, reliably, no delays, no excuses. Welcome to the world of the operational database. The best way to picture this is like a super busy restaurant kitchen on a Saturday night. An order comes in, and that ticket has to hit the chef's line immediately. This system is designed to handle thousands of individual orders, one right after another, as fast as humanly possible. It's all about getting the job done, right now. And this world has a name, OLTP, which stands for Online Transaction Processing. These databases are the workhorses, the absolute engine of day-to-day business. They are optimized for writing data, for handling tons of tiny little transactions without ever breaking a sweat. So here's the million-dollar question. If that kitchen is built purely for getting orders out the door, what happens when the restaurant owner wants to figure out which dish was the most popular last month? If they try to run that analysis on the same system, it's like stopping the entire kitchen mid-service just to count onions. Everything would grind to a halt for every single customer. And the solution? It's brilliant, really. You build a second, completely separate world, one that's designed from the ground up just for analysis. This isn't the chaotic kitchen. This is the owner's quiet office in the back. Here, nobody's worried about a single order. They're looking at the big picture: weekly reports, sales trends, and summarized data. This table just lays it out perfectly. The OLT system, our kitchen, is all about running the business. It's measured by how many transactions it can handle. But the OLAP system, the office, is for analyzing the business. It's all about how fast you can get an answer to a complicated question. They are designed for completely opposite jobs, and that's exactly why you need both. So, how do we get all that data from the crazy, fast-paced kitchen into the owner's office for analysis? Well, you need a bridge, a modern, high-speed connection between these two worlds. And that bridge is what we call a data pipeline. The real magic behind this modern bridge is a technology called change data capture, or CDC. Now, in the old days, you'd have to slowly copy the entire database every night, but CDC is way smarter. Think of it like a tiny security camera pointed at the database's internal log. It sees every single change as it happens, every new order, every update, every cancellation, and it streams that event out instantly. So here's what that pipeline looks like with some modern tech. First, CDC captures a change from a database, let's say Postgres. Next, a streaming platform like Redpanda acts like a high-speed conveyor belt, shooting that change event across the bridge. Then, a tool like Moose catches it and reshapes the data while it's still flying through the air, getting it ready for analysis. And finally, it lands safely in an analytics database like ClickHouse, ready to go. But, it's not always quite as clean as that neat little diagram makes it seem. A data engineer on Reddit really hit the nail on the head here. They pointed out that, frankly, an architecture like this has a lot of moving parts. And every moving part is a potential point of failure. It's incredibly powerful for sure, but it's not simple. Okay, so the data made it across the bridge into the analytics world, but its journey is not over yet. You can't just dump it in a big pile. The data has to be completely reorganized. It has to transform from a shape that's good for writing transactions to a totally new shape that's built for answering really tough questions. And the secret sauce for this transformation is a process called denormalization. See, in that transactional world, to save space, information is split up into lots of little tables. One for orders, one for customers, one for products. Denormalization does all the hard work up front. It pre-joins all that related info into one single massive wide table that's super easy to ask questions of. And this process often creates a classic design that we call a star schema. It's pretty intuitive. Right in the middle, you have your fact table. That's where all the numbers live, like sales and quantities. And then, surrounding it, like points on a star, you have dimension tables that give all that context. Who was the customer? What was the product? When did they buy it? This structure is the blueprint for lightning-fast analysis. So, after all of that, two separate systems, a real-time pipeline, a complete data remodel, what was the point? What's the big payoff? Well, it's this: the power to ask incredibly complex questions and get answers back almost instantly. If you tried to ask a big business question directly to that original transactional database, your query would be an absolute mess. You'd have to do all these slow, expensive joins, trying to stitch together data from all those separate little tables. It's a total performance nightmare.
But in our new analytical world, just look at this query. It's beautiful, it's simple, it's clean. We're just asking it to add up the totals from that one big pre-joined order fact table. All the heavy lifting was already done when the data arrived, which makes this query unbelievably fast.
So how fast are we talking? With a modern setup like this, that entire journey, from your click on the website, through the pipeline, to being ready for analysis, can happen in under 1 second. That's not a typo. Under 1 second. This is the magic that powers all those real-time business dashboards you see. So, here we are. We've built these incredible systems that can move information from a simple action to a deep insight at nearly the speed of light. The technical problem of speed is, for the most part, being solved. The new challenge, the much harder one, isn't technical at all. It's human. Now that we can know almost anything, instantly, what are the right questions we should be asking? And what wise decisions are we going to make with those answers?